Okay, welcome in this tutorial number 3. So we will finish the meeting number 2. Okay, the last part of the meeting number 2, and after that we will start the meeting number 3. Okay, so in the last part of the meeting number 2 deals with the problem solving. Okay, how to solve problems. Okay, how to write good and correct algorithms or correct programs. Okay, so we will go from ideas to programs. Okay, so we will start. We will have some program specifications. Okay, these program specifications typically arise from problems which may be expressed in English. Okay, you will have some sentences in English, such how do I calculate the price of some theater, for example, tickets, or game, or calculation, okay, or any similar inquiries. Okay, so this is what does it mean, problem specification. You will have a problem written in English. Okay, you will have some words, keywords, okay, that you need to understand from these keywords what is the right programmation for that. Okay, so the problem solving in the context of programming, okay, involves working from a specification to, okay, we will start from specification, we will go to the implementation. After that, we will go to the testing and debugging at the end. Okay, so implementations of the program that does the task required. Okay, so it is a solution to the problem that you have in your program specifications. After that, this program will be tested. Okay, so you will check whether a program really does the solve the problem as required or has some errors, bugs. Okay, and when you have some errors or bugs, you need to do the debugging. It means that you need to identify and fix any bugs, okay, any errors. Okay, you need to find it to keep your program work, okay, to keep your program work on the right form, okay, in the right and does the task required, the required task. Okay, so algorithms and problem solving. Okay, so now we will see a new word, which is the algorithm. What does it mean, an algorithm? Okay, so from this program specification, you will go to the implementation, and this implementation you need to write for this implementation. Before the writing of this implementation or this programming, you need to write your algorithm. Okay, خوارزمية. Okay, the algorithm can be considered as step-by-step instructions. What is an algorithm? It is step-by-step. Okay, to complete a particular task, to solve a problem. Okay, so you have a problem, you need to follow some steps, okay, to go to the solution, okay, of this problem. So to create a program, we need to be able to set out a step-by-step solution. It is called an algorithm. Okay, what does it mean, an algorithm? It is a step-by-step solution for your program. Okay, however, the raw material we start with, which is the specification, okay, the program specification, is often quite unstructured. Okay, you need to structure, okay, structure your ideas, okay, to keep your ideas in the right order. Okay, so identifying the steps needed in an algorithm and writing them down clearly is a key skill that needs to be developed. Okay, and it requires lots of practice. Okay, you need lots of practice. Why? To learn, okay, how to write a clear step-by-step algorithms. Okay, because from the beginning you will have the specification program. The specification, it is quite unstructured. Okay, you need to keep this idea in the right order, clearly defined, okay? And how you can develop this skill in you, okay? This your skills, you need to practice a lot of exercises, okay? So taking the problem solving process in two stages, okay? So you will have the design and you will have the implementation, and these two stages will make things easier, okay? Is it clear? So the design, what does it mean, the design? The first, you need to order your ideas, to make your ideas as clear as possible, okay? But after, why? Because we need after that to implement these ideas. We need to program it, okay? To go to programming language, okay? So designing an algorithm, implementing in a program, for example. So look at this example, creating an algorithm in simple natural English. We can create an algorithm with English, okay, with sentences. For example, we will write multiply the number of full price tickets, okay, by full ticket price, okay. So you will have, for example, 15 tickets, okay, and for each ticket will cost, for example, $1, okay. So you need to multiply the number of full price tickets by the full ticket price. Set the total for full price to the number of full price tickets multiplied by the full ticket price. So it is another for example, here another English, okay, creation of algorithm in simple English. Look at the program specification and then design your algorithm. Make a set of tests intended to uncover any ways in which the program does not meet the specification. Okay, so this is how you can write your good and you solve your problem. Okay, so you need at the first look at the program specification, then design your algorithm. What does it mean, design your algorithm? Write your step-by-step instructions, okay? Make your problem as clear as you can, okay? And after that, make a set of tests intended to uncover any ways in which the program does not meet the specification. You will test the border, for example, cases. You will test the special cases, okay? And in testing, only valid data are involved, including extreme situations, such as an input of 0, for example. So, okay. So look at this example. Okay, this is an example of testing. Okay. So acceptance testing is a key stage in commercial software development. It is a very important, okay, stage. A client will not accept new software unless they are convinced that it does the job required, okay? When you write a program, when you work, imagine that you work in a company that the aim of this company is to develop, okay, software for others, okay, for other company, okay? And you will have a customer that need to write to program it, okay, to program software that, for example, for shopping, for example, okay? So you need, if your customer test the software, okay, and find some errors, some bugs, okay, it will not accept it, okay? So you will lose your market, okay? So convincing them involves carrying out sometimes thousands of tests to check every conceivable aspect of this specification, okay? How you will convince them, the customer, that your product is very genius, okay? So you need to make some tests, okay? And even thousands of tests, okay? And all these tests should be, or should involve a good results, okay? As the specification, as it is indicated in the specification program, including every possible combination of different kinds of input. So we can set this out in a small table showing the inputs with the expected results, okay? And the next step is to run the script with each combination of inputs, then start debugging if there are any errors. Okay, so you can check. So look here, for example, when you don't have any tickets, okay, that was sold, okay, so you will have 0, the total, okay. When you have only full price, so you will have only one full price ticket, okay. For the concessionary tickets, it will be equal to 0, okay. For the only concessionary, okay, it will be only the price of the concessionary. For the only one from here and one from the other, okay, so it will be the sum of one full price ticket and one concessionary ticket, okay. And for then more than one, okay, so do you look at, there are many tests. We need to test the several combinations of this program, okay. Why? To convince the customer that your software work properly, okay, worked in a good way, okay, and in the required, and yeah, after implementation, yeah. Look here, the next step is to run the script with each combination of inputs, okay? So we'll have, from the program specification, I can draw this table. After that, I will enter these numbers, okay, in the test, okay? And I will see the result from this implementation. If it is the same results, it means that my program works properly, okay, in a good way, okay. But if there are, for example, I put one full price and I will get here 6.5, okay, so there are some bugs, some errors. I need to check, I need to correct these errors, okay. So in trying to trace and fix a bug, it is useful to bear in mind common errors. There are common errors that you keep to bear in mind these errors that tend to be made in the sort of programs you are testing, such as even you need to check if there are incorrect data stored, okay, or the data stored in the wrong variable. Okay, for example, here the price of the full price tickets, okay, it will be equal to 8. The concessionary the price ticket, it will be equal to 6.5. I can make some changement, okay, by mistake. Incorrect variables used in calculations. I need to check my variables if it is the right variable is used or no, okay. I need to check the wrong number block used, okay. For example, the addition instead of the multiplication, the addition instead of the division, okay. So this is okay. I can use wrong block, okay. Steps implemented in the wrong order, okay. Initialization incorrect or missing. I need, for example, for some variable to be initialized, or some initializing are missing, okay. So I need to check that. Or incorrect nesting of calculations. What does it mean, nesting here? When you have one block inside the others, okay. For example, if else, okay, and inside this if I have another if, okay. So I need to check when this nested, okay, of calculation of these, for example, selection or repetition or whatever the type of this block, okay, is correct or not, okay. So this is some common errors that you need to bear in mind, these errors, okay, because rarely you will have others errors. Always this is your errors, okay. Okay, look at this problem solving. It is a worked example. So in a particular supermarket, the normal price of 1.5 liter bottle of cola is £2, okay. However, sometimes there is also a special offer for the same brand of cola, okay. So this is a problem. What is called this paragraph? It is the program specification, okay. It is called the program specification, okay. So we need to go from program specification to the implementation, okay. How we can go to the implementation, we can write in the first, okay, here we can write, we need to write the algorithm. Okay, so what does it mean, an algorithm? The algorithm is the step-by-step, the algorithm step-by-step, okay, in which you will, you will solve, you will write, you will keep your program as structures as you can, instructions, okay. So after the implementation, we will do some testing, okay, and from this testing, we will see if there are some bugs, some errors, okay, we need to correct them. So this is the standard, okay, the normal ways, okay, in which all the programs that are written in whatever the language, the programming language is the same. We need from the program specification to write the algorithm. From this algorithm, we can write your implementation. Sorry, and from this implementation, we will carry some tests. Okay, we will test your implementation and see if you have any error. Okay, so this is my program specification. A program is required to ask the user the conditions of the special offer. So I need now to write program. What is the aim of this program? What is the task of this program? Is to ask the user the conditions of the special offer. For example, the price of the special offer, how many bottles the offer involves, and the volume of each bottle in the offer, and so on, okay? And then to tell the user the difference in price per liter to the nearest penny between the special offer and the normal offer, so that the user can decide which to buy. If he need to buy in the normal price or with the offer, okay? So he need to calculate that, okay? So we need now to, as a first step, we need to go from program specification to design your algorithm. This is the design of the algorithm. So we need to ask some questions. What data is needed? Okay. So for example, here the supply data is the price of the special offer, the number of bottles allowed in the special offer, the volume of each bottle in the special offer, all these as inputs, okay? And the fixed data can be the normal price, the normal volume, okay? So all these fixed data, okay? And this is the supply data is to put, okay, to enter, okay? Next, what more precisely is required? What more precisely? Okay, now we need to go further, okay? So we need to calculate the difference, okay? Special offer price per liter minus the normal price per liter rounded to the nearest penny, okay? We need to calculate the difference between the special and the normal price, okay? And output the rounded difference. I will show, okay, I will say the output, okay, the difference. If there are some difference between them, okay. Now write down a first draft, sorry, to the algorithm by clearly defining the inputs and testing out and setting out this outline process, including its results, okay. So I will input the price of a special offer. I will input the number of the bottles in special offer. We have only allowed number, okay. I will input the volume of the bottle in the special offer as a fixed data, the normal price, the normal volume, okay. And I will calculate the difference between the special offer price per liter and the normal price per liter, and I will output the rounded difference. So this is more clearly, you look here, this is the steps, okay, step by step algorithm, okay. Different people may do this in slightly different ways. We can have different, okay, leading to different algorithms, but we will have the same solution, the same results, okay. So here, for example, I will calculate the special offer price per liter. I will calculate the normal price per liter. I will subtract the latter from the former, and I will round the answer, okay, the answer to the, and show it to the customer, okay. So this is the steps of the algorithm. So imagine the volume of a bottle were 2 liters and its price is £4. Okay. So I can see that the price per liter would be £2, and I will get that by dividing the price by the volume. Okay, so this is how we can calculate the normal price per liter. Okay, so the general algorithm I can apply for the normal offer is set the price per liter of normal offer to price of normal offer divided by the volume of the normal offer. I will calculate the price per liter to the special offer and calculate to the difference. Okay, so this is one way to solve this program. Okay, is it clear? And after that we will implement this algorithm. So this is one way of implementations. In the first I will define my variables, my constants, okay, and my initialization. Okay, so the normal price is £2 to the normal volume is 0.15 liter. Okay, there are known values known as constants. It will be the normal price and the normal volume. Do you remember that when we have seen the variables, we see that when we have variables that are written in capital, okay, it will show that there are constants. Okay, so the constants, it is some agreement, okay, to understand the program. Okay, so the normal price and the normal volume are constants. Use the following variables. Look the variables. The variables should be meaningful variable. Okay, so the special price, the special number of bottles, the special bottle volume. Use the following variables to store values needed during the calculation. So I need the normal price per liter, the special total volume, the special price per liter, and the difference and rounded difference. Okay, so implement, and after that implement the special price per liter will be less than the normal price. Then why we are writing the first? No, it is not. We will see if it is less or more. Okay, it is, we need to calculate. We need to calculate per volume. Okay, so this is why we need to tell to the user if he needs, for example, 1 liter. So 1 liter will be will get this 1 liter from the normal price. For example, more than 2 liters, he can buy with the discount. Okay, the special offer. Okay, so we need to tell to the user or to the customer if he need to buy in special price or in normal price. Okay. Okay, so this is the do activity 2.18 and activity 2.19. It will be dealing with this problem. Okay. Okay, no, sorry, 2.17. It will be with this problem of a special price and per liter, and tell the user. Okay, you will have other programs or activities that you deal with funds and games. Okay, so you can go to your texts, okay, and practice answers to self-assessment activities. Okay, okay, so this is, do you have any question here in these steps? Do you have any question? Is it clear? Okay, clear how to okay, clear how to do, okay, to go to the right. So what does it mean, an algorithm? What is an algorithm? Or what is the definition of an algorithm? How to go to the activity? This is how to go to the activity from the CLMS. This is the CLMS, the LMS, sorry, the LMS. And in the LMS, this is your LMS. In the LMS, you will have these software activities. Once you click on these software activities, all these activities will be downloaded. Okay. and you will open these exercises and try to understand them, okay? Even you can understand the program, and after that solve this program with your way, okay? There are many ways in solving the programs. All these results will be the same, okay? But the way of solving will be different, okay? So this is how to do your activities. It didn't show up. What do you mean? What do you mean? Nothing? Why nothing? Yeah, you have to open it using Build. Yeah, sure. It is using this program, okay? Yeah, open the files, and if you have some troubles with Build, you cannot install this program. You can write the online website and open these, okay? Scratch this one. You can open this link, okay? And if you don't have the program yet, you don't install this program yet, okay? You can have the online version, okay? And you can open it easily. This is your activity, so try to open your activities. You will have this part, okay, and all this part will be in Build. So you need to open it, just this, okay? And you need to understand the program. What does it mean? What does the program do? Okay, and do it again by yourself. Okay, let's go now to the next activities or tutorials. Sorry. So today we will have tutorials about selection. Okay. Okay, so we finish all about the numbers, about the variables, about the constants, about the lists, how to create a list, how to add the parts to the list, to insert, to delete some parts from the list, also from the string, okay? The length of the string, how to concatenate, to join strings, etc. Okay, so in this meeting, we will talk about selection, the if clauses, okay? So the selection, sometimes called branching, okay, occurs in a program when the actions to be taken depend on conditions. Now, we will, for example, create a list once you have, for example, some grades, for example, okay? Or once you are enrolled in courses, okay? So we need to check if you are enrolled or not in for example, in courses. After that, I will ask you your courses, okay, to store these courses in a list, okay? So here we have what? We have some condition. We have the program, okay, occurs when the action to be taken depends on conditions, okay? So we have different conditions and different actions to do. So all programming languages provide structures to enable selection. All the programming language, you will have these if clauses, okay? And in this meeting, you will meet some of the key Build blocks used in implementing selection, okay? So let's begin by Boolean block. What does it mean, Boolean? Okay, Boolean variable, it means that this variable can be even true or false. So Boolean blocks report either true or false according to whether or not a particular condition holds at the moment the block is run. Okay, so I have a block to be run. Once it is running, it will show either true or false. Okay, so they are reporter blocks distinguished by their hexagonal shape from other reporter blocks. Okay, it will be with her hexagonal. Okay, this is the shape of this condition. Okay, and Boolean values underlies computing because computing fundamentally relies on binary, the ones and the zeros, which can also be thought of as equivalent to true and false. Okay, so this is why the Boolean is a very important values in the computer science. Okay, okay, selection blocks are found in the control palette. When we can find this, I don't understand you. The activities including marks or just no, just for training, for you. Okay, there are no grades for that. Okay, there is no 2.17 exercise in the folder. Okay, no problem. Try to do it by yourself. Already we have solved this exercise. Okay. So all the algorithms, you have all the algorithms, all the implementation. Okay, try to write it. Okay, and you will and test. Okay, your program, test your knowledge, test your skills. Okay. So the selection blocks are found in the control palette, where you can find these if clauses in the control palette. Okay, there are two forms of these selection. We have if then. Okay, if this condition is true, then do the following actions, and if then else. Okay, so here if it is true, you will do all the instruction after the then. If it is false, okay, the action in the else, okay, block will be executed. Okay, so all this then will be skipped. Okay, so they instruct programs to select which actions to take next. There is where the next come. Okay, so this is the two forms of the if clauses: if then and if then else. Okay, so when an if then block is run, OU build checks the condition. This is the condition here. This is the shape of the condition. It is the Boolean block. Okay, it is a Boolean block. Okay, hexagonal shape. Okay, so if it reports true, this condition, if it is true, okay, then OU build runs the if part, the blocks between the jaws, this part. Okay, if here we have a true. Okay, this is true. All these actions here will be, or instructions will be run. Okay, but if it reports false, OU build ignores the if part. If here we have false, so all this part will be ignored and it will be skipped and go to the others instructions after the if clauses. Okay, but if you have when an if then else block is run, so OU will check the condition. This is the conditions. If the condition is true, so all these part the if clause will be run. Okay, if it is false, if we have here false, so all this part will be skipped and the else part here will be executed. This part, okay, in the else. Okay, so if it reports true, or you will run the if part. If it reports false, or you will run the else part. Okay, in both cases, OU build then moves on to run the next block down if there is one. Okay, here, if there is here one. Okay, below the if then block or the if then else block. Okay, so is it clear right now? You have any question like right now? Any question? Clear? Okay, good. Okay, look at this activity. We will try this activity. Okay, so activity 3.1 in your folder, in your practice 2. Okay, is a spelling game. Okay, it is what? A spelling game. What does it mean, a spelling game? It means that it checks if the user's spelling is correct or not and display a message accordingly. Okay, so if the user spelling is equal to this word, okay, then say well done. Okay, else say wrong. Press your spacebar, for example, to try again. Okay, so this is one example how to use the if else. Okay, this is another activity. The activity 3.5 is a guessing game that works by pressing the A key as follows. Sets a secret number to a random number. Ask the user to enter their guess and determine whether or not the guess is equal to the secret number, and inform the user accordingly by telling them either lucky guess or unlucky, press your A to try again. Okay, so this is another type. Let's try this this exercise. Okay, this exercise you have already this exercise. So look here, it is exercise 3.5. This is 3.5 if you see it. Okay, so this is in the first. Okay, when you have the 3.5 and 3.5 completed here, it means that all the program is done. Okay, but here we have open what? We have the beginning. Okay, completed. It means that the whole program is written. Okay, in all you build. But here 3.5. Here it means that the program is in the first. Okay, so look here, for example, when we can use when the green flag is clicked. Okay, set secret number to pick random. Okay, here we will choose randomly one number between 1 and 50. Okay, and after that we will go to the guessing game. Okay, so when A is pressed, ask guess my number, set user guess to answer. Okay, and after that I will go to the control, to the if. Okay, if then or if then else. What shall I use? If then else or if then. Okay, I will look to my program specification. In my program specification, I have what? I have to tell the user lucky guess or unlucky. Okay, so I will to communicate with the user in both cases. Okay, so I need to use the if then else. Okay, so if here I have some operator. If the user guess is equal, so this is the user guess is equal to the secret number, then I will say, okay, sorry, I will say lucky. Okay, lucky guess. Okay, okay, I will say that you have a lucky guess. Okay, but if it is not equal, I will say try again. Okay, unlucky. Try again. And how he can try again. He need to press on the A. Okay, so press your try again and press the key A here. For example, why here A? Because here the program will start when A is pressed. Okay, the key A. Okay, so we can test this program. So this is the number. Okay, I need to see the secret number. So this is the secret number. It is 4. Okay, so we need to guess. I will press A. Okay, once I press A, he will ask me to guess my secret number. Okay, so I will write, for example, now 15. Unlucky. Okay, I'm here now. Again, A. Guess your number. 20. Unlucky. Try again. A. And I will write now 4. Okay, so lucky guess. Okay, so by this method, okay, by this testing, I am sure that my program working well. Okay, my program does the required task. Okay, is it clear? Okay, do you have any question? Is it clear right now? I think it is very easy, yes or no? But you need to practice. You need to practice, okay? One more. Okay, another example. Okay, so look here. Here, what is the aim or what is the object of this program? We need to guess the number. Okay, so there are one number, secret number. This number is picked randomly between 1 and, for example, now between 1 and 10. Okay, and after that we will ask to guess this number. Okay, for example, here. So the number here, the secret number is 10. Okay, and I need to press A to start the guessing game. Okay, so this is A. It's my number between 1 and 10. For example, 2 here. Unlucky. I will press A again. 5 here. Unlucky. I will press A again. And after that, I will write X 10, for example. So lucky guess. Okay. Is it clear now? I think, is it very clear? Okay. Okay, let's move on. Selection numbers. So in the selection numbers, we have already talked about the Boolean comparison. Okay, blocks are used for comparing numbers. Okay, when we have some selections that we need to be used. No. Normally, the users don't know the secret number. Okay, so just I show you the secret number to test. Okay, to see when it is right, when it is wrong. Okay, just for testing. But in the game, no, it will not be shown, and it is a guessing game. Okay. The Boolean comparison blocks are used for comparing numbers. Okay, when we have numbers to compare, we need, for example, like now, like this number with the guess number. So we need to use the Boolean comparisons equal, greater, or lower. Okay, these blocks work with positive, negative, zero, integer, and decimal number inputs. they compare one number with another as follows. Okay, so this block will report true when the first number, this is the first number, is less than the second number, and will report false where it is not. Okay, this block will report true when the first number is equal to the second number, and false when they are not equal. This block will report true when the first number is greater than the second, and false when it is not. Okay. The number blocks can be nested within comparison blocks. So this is look at this block. Okay. So here we have 2 greater than -1 multiplied by 2. So I will carry this one because it is a nested comparison. Okay. I will carry this calculation, and after that I will carry this one. Okay. So -1 multiplied by 2 is equal to -2. And after that I will compare 2 is greater than -2. Yes, true. Okay. Okay, look at this. Look at this equation. Okay. So I have 1 plus 1.5, it is equal to 2.5. Multiply by 3 is equal to how much? Okay, this one, is it equal to 5.5? Yes, 7.5. So it will report false. Okay, so this nesting, it is like the parentheses. Okay, I have this parentheses. Okay, I need. Okay, it is 2.5 multiplied by 3, Ibrahim. It will be equal to 7.5, not 6.5. Okay, okay. When I say 1 plus 1.5 multiplied by 3 is equal to 5.5 for 2 seconds. When this will show this reports false, so it will be displayed. False will be displayed. Okay, so I can use it. Okay, like this. Okay, okay, is it clear? See here. Okay, so I have some comparisons. This is the comparisons. I have like this. Here 2. Okay, 2. Here I have the multiplication. -1 multiplied by 2. Okay, so give me the results for that, for this number selection or this boolean. Okay, we will use say. Okay, for 2 seconds or for 4 seconds. Okay, so give me the result before we it will show the true or false here. Okay, true or false? Tell me, what is the results? What the oil here will say? This is true or false? So you need to check. -1 multiplied by 2 is equal to -2. Is it -2 greater than 2? Yes or no? Here, it will say false. Okay? Are you with me? Okay, good. False, okay. It is no false. Here we have true or false. Boolean true or false, okay? But when we have here -5, okay? Okay, so when, okay, now the result, true or false now? Look, -5, is it lower than -1 multiplied by 2? True, good. So it will report true. True, good, okay? Okay, let's see now the other. Okay, when we have some equation now, operators, so I don't need this greater than. Okay. Okay, I need now an equation. Okay, so here we have okay, so is it clear for you? The nesting now here we have 1, here we have 2 or 4 multiplied by 5. Is it equal to 20, 25? Yes or no? Tell me it is yes or no? True or false? Yes. No. Good. No. Good, Sadia. Good. Turkey. Why? Because here we have 4 multiplied by 5. Okay? It is 20. And after that we have plus 1. It is 21. Okay? Yeah. So when I will say, it will report false. Yeah. Good. Okay? But here when I write 21, it will report true. Okay? Okay? So you will have like these questions in quiz number 2. Okay? I will show you some part of the OU build and I will ask you for the result. So be okay, be attentive. Okay, be aware of that. You need to check the nesting. Okay, when you have this one, it means that like the parentheses here. Okay, if you have, for example, here like that, for example, here, it is like the parentheses here. Why it should? No, it is not like that. No, Sadia, look Sadia here. Look here. Do you see that? This is a nesting here. So we will not carry the multiplication before this one. It is like the parentheses when you use this nesting. It is like the parentheses, okay? If I need to carry the multiplication first, I need to use 1.5 multiplied by 3 in the same block, okay? And not with this part, okay? Okay. Structure of computer program. So selection, it is called also the branching. So programming structures that allows an instruction either to be executed or skipped over according to some condition. So this is the definition of the selection. Okay, it is a programming structure that will allow instructions to be either executed or skipped. Okay, it is according to some condition. So conditions are statements that can be either true or false, such as it is running, the traffic is very heavy. Okay, when this condition is met, okay, is true, it will be all these statements, all these instructions will be executed. In mathematics and computer programming, true and false are something or sometimes referred to as Boolean values, and the condition that can be evaluated true or false is referred to as Boolean expression. Okay, so examples on Boolean expression, when we have 4 greater than 10, when we have 3 multiplied by 3 lower than 9. Okay, all these are Boolean expressions. Okay, so it will report true or false. This one, 4 greater than 10, true or false? It will be false. Okay, yes. And this one, 3 multiplied by 3, is it or it is greatly lower than 9? False. Okay, it is equal, greater or equal. Okay, or lower or equal. Okay. Okay, so if it is snowing now, put the cat in the kitchen. If it is not snowing, put the cat outside. Okay, so this is one program specification. Turn out the lights. Okay, so what is the condition here? The condition here is if it is snowing or not. Okay, so if it is snowing, okay, and there are two possible courses of actions. Okay, so what is the first? It will be the first one is to put the cat in the kitchen when the condition is true, and put the cat outside when the condition is false. Okay, so if the condition is true, we carry out the first instruction and skip the other second to whatever follows next. And if the condition is false, we skip over the first part, okay, and we carry out the second instruction. Okay, so once we have executed one or the two of the other, we move on to the any other instructions which will be turn out the lights. Okay, so look, this is my program. Look here. If it is snowing, put the cat in the kitchen. Look at the indentation. It is very important to understand your program with the indentation. Okay, this indentation mean that this put will be executed when the if inside the if. Okay, the first part. Else, put the cat outside. When we write turn out here, okay, it means that then this instruction is outside the if clauses. Okay, it is not included in this part. Okay, but if I write turn here, okay, so it means that this turn out the lights, it is included with the else part. Okay, so this is the benefit, okay, of the indentation. We could perhaps write our instructions as figure. So note that the use of parentheses to make it clearer which part is the condition. This is the parentheses, the condition. As the use of indentation, okay, also the use of indentation to provide a clue as to which parts of the structure are dependent on whether the condition is true or false. And the fact that turn out the lights is not indented, okay, there are no margin here, it means that it is not part of the selection part. Okay, if it is here turn, okay, if it is margined or indented, turn here, it means that this instruction is inside the if clauses and especially in the else part. Okay, but because it is not indented, there is no margin here, it means that it is not part of the selection structure. So this is the benefit of the indentation. It is very important when you write your algorithm, and sometimes you will be penalized, okay, if you don't respect indentation in your TMA or in your FTHE. Okay, there are some points for the indentation, 1 point, 0.5 for the indentation. Okay, so try to respect this indentation. Why? Because it will make, or it will help the evaluator on or the others to understand your program. Okay, and many high-level programming language do use the words if and else to indicate the selection structure. Okay, so this is the structure of the flow chart. We can use the flow chart, and be aware of that. You can be asked in your TMA or in your FTHE or whatever your assessment for either to write your or to draw your flow chart, or from the flow chart you need to write your OU build. Okay, or to explain the flow chart. So you need to understand. So the first alternative, put the cat in the kitchen, is referred to as if branch in the true. Okay, and the second branch, put the cat outside, is referred to as the else part. Okay, so this is true. When this condition is true, I will put the cat in the kitchen. When the condition is false, I will put the cat outside. And whether I will put the cat in the kitchen or the outside, okay, I will turn out the lights. Okay, so turn out the lights will not depend on these conditions. Okay, it is separated from these. It is not a part of these if clauses. Okay, is it clear? Do you have any question right now? Clear? Okay, thank you. Okay, sometimes it is more convenient to express a condition in the negative form, okay? So look at this example. In programming language, the not appears before the Boolean expression to make it quite clearer what we are negating, okay? What we are, it is not right, okay? So the English word not is usually represented in Boolean expression by the word not in uppercase, okay? Not, it is called a Boolean operator, okay, as you know. We have the not, we have the and, we have the or, the and, etc. Okay, all these are Boolean operators, and because it operates on a Boolean expressions, okay, it is also an example of unary operator. What does it mean, unary operator? It means that it will require only one operator, one side, okay, which means that it operates on a single value, okay? So not something that evaluates to true will give you false, and not something that evaluates to false will give you true, okay? So look at this example. If the customer is not an adult, okay? What does it mean it's not an adult? It can be a teenager, it can be V1, okay? An older man, okay, etc. Okay, it is not an adult. Okay, so here what is my condition? It is not an adult. The customer is not an adult. Okay, so it will pay £5, else it will pay £10. Okay, so if it is an adult, okay, it will pay £10. It will, if it is not an adult, it will pay £5. Okay, and admit the customer. Okay, so look, admit the customer here. It is not a part of the if else. Okay, look here. Either we have a true or false, we will admit the customer. So the admit the customer, it is not a part of the selection part. Okay, so here it is a selection structure for admitting a customer, but with or not in the Boolean condition. Okay, not an adult. Okay, so we can use this not in your Boolean condition, okay? Okay, look now at the sequential versus the nested selection, okay? Sequential here and here we have the nested. So we will look at the difference between the sequential and the nested, okay? So suppose the specification of the guessing game changes, okay? So we have this program specification of guessing, but here we have some changes in the program specification. For the same game, it is a guessing game, okay? So the script should give the user some information about an incorrect guess as follows, okay? So here we will have some explanation, okay, to help the user guessing the right number, okay? So I will ask the user to enter their guess at the secret number. So this is the same, okay? And I will determine whether the guess is equal to, less than, or greater than the secret, okay, to help them, okay? The secret, and inform the user accordingly by telling them either I will tell them that it is a lucky guess, okay? So this is the same as the first specification, but this is the difference. For the unlucky guess, I will give him more what? More explanation, okay? More details, okay? If it is too low, I will, if the number is, yeah, the number is greater, okay, then the guess, so I will tell him that it is too low, press A to try again. If it is greater than the number, I will tell that is too high, okay? So this is, for example, so in this case, there are 3 different courses of action to be taken, each when a condition holds, okay? We don't have either if it is true or false, yani either if you have a lucky guess or unlucky guess. No, we need to compare. We have 3 conditions. we need to tell if it is equal, it will tell the user that good or lucky guess. If it is greater than too high, if it is lower, too low. Okay. So look at this example. It is the same example. So figure 9 shows one possible sequential structure. What does it mean, sequential structure? Okay. We have if, after the if we have another if. Okay. We have a sequence. Okay. متتالية. Okay. So we have if clauses one after the other. Okay. One after the other. Okay. Okay, solution one after the other. This sequential structure works here because the conditions involved are mutually exclusive. What does it mean, mutually exclusive? It means that only one of them can hold at any one time. Okay, if it is equal, it cannot be greater or lower. Okay. If it is greater, it will never be equal or lower. If it is lower, it will never be equal or greater. Okay. So for any user input, only one of the 3 conditions reports to, and so only one action is taken. Okay. So look at this. This is one trial. Okay, of this changement in the specification. Are you with me? Is it clear? Is it clear? This is one way. If press will not change, no, it is not. It is not the if when a key pressed. It is an event, just an event to start the program. We can change it, but either if it will be when A pressed, or when flag green pressed, or when B pressed. Okay, just an event to start the program, only that. Okay, but here we need to change the program itself. Okay, the working of the program. Okay, are you with me? Okay, so this is one way of solving this changement. Okay, in this program. Okay, so I will. Okay, we will do this program. So look at this program. Look here. This is the OU build. Okay, we need a new file. So in this new file, we can use any event. Okay, this one, this one, this one. Okay, this one. It is not. It will not have any changement. Okay, do you hear me? Okay, so I will ask the user. I will ask. So in the beginning, I need to guess the number. Okay. Ask the user. Sorry, what is ask? Ask. Choose. Or it is not to choose. I will just. No, I will just make a variable called, for example, here secret number. Okay. This is my secret number, and I will use set secret number to what? Set secret number to random. Okay, I will use the random. This is the random. It is a number between 1 and, for example, 20. Okay, or 100. Okay, for example. Okay. And after that, I will ask. Sorry. Where should we write the algorithms? It is before this implementation of the algorithm. Okay. From the program specification, we can write the algorithm. So, sorry, I will ask. I need one event. This one. I will ask the user guess the number. Okay. Guess my secret number. Okay. And I will set a new variable called user guess. Okay, I will set my user guess to the answer. Okay, and after that I will compare. Okay, if this is the if, then if the user, I have 3 if. Okay, 1, 2, and 3. Okay, for the operators, I have one with equal, I have one with greater or lower, and one with greater. Okay, so here I will compare. Compare what? The secret number with my user guess. The secret number with my user guess. The secret number with my user guess. Okay, so if here I will use the say. Say, okay. If the user guess is equal to the secret number, so I will write, or I will tell you lucky guess. Okay. The user guess is lower than the secret number, I will tell him that is lower now. Too low. Okay. Too low. Try again. Try again. And press A, for example, here, because we have no, not press, and press space. Okay, we have used space as a key to start the program. Okay, here space. Okay, for that too low. Okay, it is the same. Too high. Okay. Okay, so now I will now show to you the secret number. Okay, I will show you only the okay. So we will start. Okay, so the secret number is chosen. Okay, is randomly choose. Okay, and after that I will guess my number, my secret number. Okay, try. For example, 20. Too low. Try again. It is now 20. More than 20. Okay, press 25. Too low. Still too low. Okay. 30. Too low. Still. Okay. 35. Too low. Still too low. 45. Too low. 50. Too low. Still too low. Okay. 60. Too low. 70. Too low. 80. Too low. 85. 90. 91. Too low. 92. We need to see my secret number is 97. Okay. So do you see that? Is it good or no? My test. shows that my program works well, okay? Okay, are you with me? So this is one way of solving this program specification. We have used here the sequential if, okay? The if clauses. So look at the other examples. Okay, so this is the sequential. So this is the correct. So figure 10 shows the flow chart of the sequential structure. Solution shown in figure yeah, I'm not lucky, yes. Okay, solution shown in figure 9, okay. So if the user guesses correctly, the first selection block is run, its Boolean condition reports true, so the user is informed, okay. At this point, since the guesses have been found to be equal, so it is clear that the guess cannot be less, okay. So it will be go from false, okay. What do you mean, Firas? I don't understand. Where did you study college? I don't know if you ask from the branch or the branch. I am from Medina. Okay. Okay. However, the subsequent two selection blocks are run anyway with their Boolean condition reporting false. Okay. So these blocks have no effect, but the comparison are still made unnecessary. Okay. So do you think that it is a good idea? Okay. When we use the sequential if, okay. What do you think about this solution? Okay, it is a working solution, but is it a good solution? Is it a good solution? No, it is not a good solution. Why, Sadia? Tell me why it is not a good solution. Why it is not a good solution? Why? Why it is not a good solution? Sadia, why? It uses two more resources to recheck at every if statement. I need more because it has grown to all the if statements. Good. This is what I need. Because program has to go through all the if statements, even if I am sure that it is equal, I need to check if it is greater or and to check if it is lower. Okay. So while in the same time it is not required. Okay. If I have equal, I can skip the others comparisons. Okay, so this is why this sequential programming is not good in this case. Why? Because I need to check all the comparisons, while from the beginning, for example, I have that it is equal. Okay, so I don't need to check if it is greater or lower, and if it is greater, I don't need to check if it is lower. Okay. So I have many resources, many resources that will be used useless. Okay. So this is what does it mean now, the nested selection. Okay. So figure 11 now show another possible solution for the same program, but with nested structure. Okay. So nested structure means that one nested inside the other, okay? So this is what does it mean, nested. We will have outer if clauses and inner if clauses, okay? So in this solution, no blocks are run unnecessarily. Sorry, okay? If I have, it is true, so the else part will not be evaluated, okay, or not be executed, okay. If it is no, the yes part will not be executed, etc. Okay, so in this sense, it is more efficient. So look, now we have a new keyword. It is the efficiency of the program. When I can tell, okay, that this program is more efficient than the other, okay, when we have some blocks that are running, okay, unnecessary, okay. I need to run only the necessary part, okay. The unnecessary part should not be executed, okay. It will be dissipated, okay. It will be dissipate my my memories, my energy, etc. Okay, so it will be not efficient, okay. But when there is no block that will be running unnecessarily, this means that I have a more efficient algorithm, okay. So if the answer to the first Boolean comparison is true, then the rest of the block are not checked, okay. If there are some condition that is true, all the others condition will not be checked, okay. So in this sense, it is a more efficient and elegant structure compared with the previous solution, okay. So you can look here. I will ask the user and I will compare. If it is equal, okay, I will say lucky, okay, and I will use and I will go back, okay, to the other instructions, okay. If it is not equal, it means that it can be either lower or greater than, okay. So if it is lower, okay, I will say too low, okay. So this part will be ignored. I don't need to check if it is greater, okay. If it is true lower, okay, so it is necessarily not greater, okay. But if it is not low, okay, I will use this one, okay. So this is more efficient part, okay. Both this one, this implementation, and that one will have the same results. Will answer to the same object, okay, for the program specification. But this implementation or this program is more efficient than that one, okay. Why? Because in this program we don't have any blocks to be run unnecessary, okay. All the blocks that will be run are necessary, okay, are necessary, okay. So look at this. This is the flow chart of the nested structure. Look at this flow chart. If it is true, so it is lucky. If it is false, so it can be either greater or lower, okay. Lower, okay, too low. Greater, too high, okay. So this is the nested. So I don't have any. If I have one condition met, I don't have to check the other conditions, okay. Now, compound condition with numbers. So Boolean operator are used frequently in programming, and common Boolean operator are and, or, and not. Okay, so this is the common Boolean operator. In OU build, Boolean operator blocks are those shown in figure 13. So we have the and, the or, and the not. Okay. And they are also called compound conditions, okay, since they are used for checking conditions formed by combining other conditions using the terms and, or, and not, okay. So look at these examples. When you have the and block, this is the and block, will report true when both of its inputs reports true, you know, when we have the and, okay. So we have the 0, 0, the 0, 1, okay, the different combination, the 1, 0, okay, and the 1, 1, 1, 1. So when we have the and, this is the and block, okay. Here we will have 0, here we will have 0, here we will have 0, and here we will have 1. It will report 1 if and only if both of its inputs will equal to 1s, okay. This is for the 1. For the, so look at this example. When you have 5 lower than 2 and 5 greater than 1, so what is the result? Tell me what will report this block, true or false? And also for this block, tell me. These are examples, okay? And for that one, okay? So for the 14, 1 louder than 2 is true, okay? So I need to check the second part, the second block. 1 greater than -1 is true. So because I have here true and true, it will report true, okay? For 15, 5 is louder than 2, true or false? True or false? False, okay. From the beginning, I don't need to check this one. I will write here false. Why? Because I don't have both, okay? I need to have both input equal to 1, okay? For this one, for 16, tell me for 16. For 16, 10 is louder than 20 is true, okay? I need to check the second. 10 is louder than 5 is false, so it will report false. Okay, good. Good. Good, Saif, good, Ibrahim, Ahmed, Dream. Okay, thank you for your interactions, for your response. Thank you. Okay, look now at the OR now. For the OR, the block, this block, the OR block, reports true when only one, okay? We need just one. One or both of its inputs report true, and reports false when both of its inputs report false, okay? So this is the OR. When you have, this is the OR, you have 0, 0, 0, 1, 1, 0, and 1, 1, okay? So it will report 0 only when both of its inputs report 0 or false, okay? But for the others, 1, 1, 1, okay? So look at this example, figure 17. So 1 is louder than 2 is true. So automatically this will be true. All these instructions will be true, okay? This condition. For the 18, tell me for the 18, the result, false or true? Okay, Mohammed, no problem. For 18, tell me, for 18, false. Okay, I will check with you. 10 is louder than 1 is false. Okay, I need to check the second. 10 is greater, strictly greater, it will be false. Okay, so the result will be false. Okay, good. For the 19 now, tell me what is the result for 19. Okay, Ibrahim tell you that it is true. Sadia true. Okay, let's check. 10 is louder than 20 true. Okay, so once I have only one true, I will say that all these is true. Okay, because if I have one of them is true, I don't need to check the other side. Okay. Okay, for the not now, the not block reports true when its input reports false, and reports false when it reports false when its input reports true. Okay, so in figure 20, not 10 louder than 5, 10 louder than 5. Yes, true or false? False. So not false, it will be true. Okay. True here, figure 20 will report true. For figure 21, 10 is greater than 1. Yes, so not true, it will be false. Okay. Here for figure 22, tell me for figure 22, 23, 24, 25. Okay, take your time. 22, the first 22 is easy, 22. Okay, so I have here or. Okay, so I need to check if only one equal to true. Okay, it will be equal to all the true. Okay, false for 22. Okay, we see that. So 1 is louder than 2 is true. So not true is false. So the first part here is false. I need to check the second. 1 is greater than -1 is the true. So 22, it will be true. Okay? Why false, Sadia? 22 is true. Okay? Yeah, true. Okay, for 23. For 23. True or false, 23? True or false? Twenty-three true. Marah say true. Ahmed true. Badr true. Badr false. Sorry, Ahmed true. So we will check. 1 is lower than 2 is true. Not true is false. Not false is true. So it will be true. 23. Good. Okay, true, real. Why false? Okay, so for the 24, give me the result for 24. For 24. Give me the result for 24. For 24. What is the result for 24? False. Okay, let's verify, check. Okay, so here we have and. Okay, and because we have and, we need to check both of them will be true. Okay, and if I found one of them is false, so automatically it will be false. Okay, 1 lower than 2 is true, not true is false, so automatically it will be false. Okay, it will be false. Ahmed Muqbil. Not true, Musa, not true. Why true? All this block I need. Okay, for figure 25. Tell me, what is the result for figure 25? For figure 25. False. Okay, we will check. So here we have, look, here we have this block and this block. Okay, so I need to check this block because here we have and. So if I check that this false, automatically I will report false. If it is true, now I need to check the other. Okay, so 1 is lower than 2 is true. Okay, good. So here I need to check if it is true or false. 1 greater than -1 is true, so it will be equal to true. Okay, yeah, 20. Now Victoria, it is not false, is true. Okay, okay, is it clear? Is it clear? Okay. Okay, the last one. Okay, the last one. This one. Okay, here we have and block. Okay. Yeah, for the or. Okay, here we have and, so we need to check the first, this is the first part, and this is the second part. Okay, so I need to check the first part. If it is false, so all these block will be false, because when we have and, we need both of them equal to true. Okay, so I need to if it is false or true. 1 is lower than 2 is true. Okay, so good. I need to check the other side. Okay, for the other side I have the or, and for the or, when we have one side is true, all the block will be true. Okay, I don't need to check the other side. Okay, so 1 is greater than -1 is it true or not? Is it true? This one, this block is true, and because I have or and true, so all this block will be true, and the true and the true will be true. Okay, clear now? Yes, yes, you need to the nested, you need to respect the nested block. Okay, here we have the nested loop. It is like the nested block in the operation or multiplication, division. Okay, so here we have some nested block. We don't have the or beside the and no. Here all these precedents and these like the parentheses. Here when you have this nested, it is like the parentheses. I need to check this one before this one and so on. Okay. Okay, look at this example. So figure 26 shows an example of using compound conditions in a program. It checks whether the length of the new password is less than 4 or greater than 8. Okay, so this is one, it can be used when we need to check the password, the length of the password. If, look here, if the length of the password is lower than 4 or the length of the password is greater than 8, then say invalid length. Okay, and try again. And else set password to the new password and say press set. Okay, so this is an example of using a compound condition. Okay, is it clear? So try to practice this exercise. I can duplicate. This is no here. And for this one, I need to delete all this, delete. Okay, delete. Okay, so I will ask the user. Look here, and this one and this one. So I am here. In this one, I will use, for example, this event. I will ask the user to give me, ask the user to enter a new password. Enter a new password. Okay, and I will create a variable called new password. Okay, and for this new password I will set this new password to answer. Okay, to the answer. Okay, and after that I will check in the control if else. Okay, because I have, so if what, if I need to use the or. Okay, I have two conditions to check. Even if the length of this password is greater than 8 or is lower than 4. Okay, it is not accepted. Okay, so I need now to use the length. Okay, so this is the length of, and I need greater or greater than 8. So this is the length. The length of what? Not word, of the new password. Okay, the length of the new password is greater than 8, it is not acceptable, or length of the password is lower than 4, it is not acceptable also. Okay, the length of the password, the new password, is lower than 4. Okay, So then I will say invalid length, okay? Say here invalid length and try again, okay? Press in the green flag to try again, okay? Else I will set password, okay? So I will create password here, okay? And I will set password to what? Are you with me? I will set password to new password, okay? And I will say that password is changed or password is set, okay? So password set here set for 2, okay? So this is one example of using the compound condition, okay? Are you with me? Is it clear? Yes, I will take the attendance at the end of this lecture, okay? This tutorial. So look. So enter a new password. For example, password 1, 2, 3, 4, 5, 9, okay, 10. For example, password set. Why? Because this is good, okay? Okay. Another time. For example, 1, 2, 3. For example, invalid. So press the green flag, okay? Invalid. More than 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Also invalid, okay? So with this testing, I can say that my program is working well, okay? If I have any errors, I will find where is my error, okay? Is it clear right now? Now we have selection with strings, okay? So many of the ideas you have seen in the context of selection with numbers can be adapted to selection involving non-numerical things. It is the same thing, okay? It is, for example, the project activity 3 point. No, it is not just numbers. We can do other things. Yeah, we can write numbers. We can write. Yes, we can write. Look. So this is the green flag. For example, here I can use user 1, 2, 3. Okay. So password is set user. Okay. But when I write user only user, for example, only use, okay, so it is not valid because here we have 3 characters, only 3 characters, okay. When you user 1, 2, 3, 4, 5, 6, 7, it is not valid because it is greater than 8, okay. So we can use whether a character or a number, okay. So it is a program that asks the user to enter a new password such that if the first character of the new password is not an alphabetic letter, that is, for example, one of A, capital A, B, capital B, until Z, capital Z, then tell the user that it is invalid. Character must be alphabetic, okay? And press, for example, A to again, okay? Otherwise, set the password to the new password and tell the user to password set. So here we have some other program specification changes, okay? We have changes. We don't ask only for a new password that is, for example, the length is greater than 4 and lower than 8. No, now we need the first alphabetic, okay, character is an alphabetic letter, okay? So this can be done after understanding how characters, strings consisting of are compared, okay? So all you build order alphabetic letters in sequence adjacent to each other. Okay, so we will have A. Okay, capital A is A, B, etc. until Z. Okay, so when I tell that A is greater than Z, okay, It is not true, okay? So all non-alphabetic characters are either to the left of A or to the right of Z, okay? So one way to check whether a character is non-alphabetic is to check whether it is less than A or greater than Z, okay? And this is how to check, okay? So if letter 1 of new password is lower than A, so it means that from this side, or greater than Z from the other side, it means that it is invalid, okay? Because all alphabetic are between A and Z, okay? So if it is not located, cannot find it between the A and the Z, it means that it is not an alphabetic letter. So it is invalid, okay? Comparison blocks can take any characters as input, not only numbers. So with alphabetic letters as input, note that the following, the block, greater one or lower one, are based on the usual alphabetic ordering, okay? So it will be on usual alphabetic ordering. So OUBIT considers A to be less than B because A comes before B, okay? And B less than C because B come before C and so on, okay? The lowercase and the uppercase versions of the letter are considered equal in OUBIT. In Java, for example, no, it is not equal, but here in OUBIT, the capital and the small cases, the OUBIT is not sensitive. It's not a sensitive case language. Okay, so for example, capital A equal to small a, okay, reports true. Okay, but the OUBIT generally orders character using the American Standard Code for Information Interchange (ASQ) system. However, the ASCII system, however, does distinguish between uppercase and lowercase, okay, and this is not the case of the OUBIT, okay. So comparison blocks compare words on the basis of the usual dictionary ordering, okay, it is the same thing. So the first letter in each word, it will be compared with the first letter of the other word. If they are equals, okay, it will go to the next letter. The comparison of the first letter at which the word differ determines the order of the word. So look here, when we have to compare this word with that one, okay? So it will report A is lower than A, okay? A R, okay? So here we have A and the R, okay? So it will record true. Okay, because here we have the same number, okay, the same word. Cat and camel, we have here the same and here the same, but here we have T and we have M, and M comes after T, before T, so T is greater than M, okay, it will report false, okay. Dog, capital is the same as dog small, okay. And the same, it is the same principle applies to all non-numerical strings when you have a mixed, okay, of numbers, and it will compare one by one, okay. So here we have the E capital, the E and the M, okay, from the beginning, because E comes before M, so it will report true. Here we have E and E, so it's the same. H and H is the same, so I will compare 1 with the 3, okay. 1 is lower than 3, so it will report true. Okay, is it clear? Are you with me? How we can compare the numbers or the strings and the alphabetic words? Okay. Okay, simplifying selection. So in the next activity, we'll practice implementing selection involving strings and using a flag variable. You will also meet an alternative approach to simplifying selection. Okay. So do the activity 3.11. It contains the oil spirit, okay, who will run a small I Spy game designed for children. In the game, the oil thinks of an animal and tells the user to the first letter of the animal's name, and the user tries to guess the animal. Which part do you mean, Brahim? How to, you don't understand how to compare words? words or numerical and alphabetic. Okay, words. How we can compare words? We will compare letter by letter. Okay, letter by letter. If the letters are the same in both words, we go to the next letter. Okay, so look here. You have here A and here A, so the same. I cannot make, I don't make comparison. Here A, okay, look at this A with this R, so different, so I can make comparison, okay? Because A comes before R, so R is greater. It will report true, okay? Look here, cat and camel. C with the same C, A with the same A, so I need to compare now T with M, okay? But you know that in the alphabetic order, T comes after M, okay? So T is greater than M. It is not false, okay? It is not loud, okay? So this is why this block will report false, okay? For this one, dog is equal to dog, so we have already said see that the OU build is not case sensitive, okay? So it is not matter either with the capital or the small, all the capital or the small are the same, okay, for the OU build. If when we have some letters with numbers, so it is the same rule, okay? I will compare E with M. So E comes before M, so E is louder than M, true. Here I will compare E with E, it is the same, so I will go to the next character, H with H, so it is the same. So 1 with the 3, 3 is greater than 1, so it will report true, okay? Is it clear? So you have this exercise 3.11, okay? So you can you have already the solution for that, so you can see if you can do it by yourself, okay? So look here, I need to enter this is the game. I need to, in the first, to initialize the list, okay, and fill the list with the names of animals, okay? And after that, how these children will play? He will click on this spread, okay? And from this click, the OIL will choose one animal from this list and will give you the first word, okay? And you will guess the name of this word, okay? So you don't have any idea about this list as a player, okay? But you need to guess, okay? So this is an example. Okay, simplifying selection. So the activity, for example, 3 point. So all these will deal with the same exercise. So I will initialize this list of animals with animal names. I will set a constant called password to hood, for example, and set a variable password correct to false and click on me to enter the password. So the password correct here will be a flag variable. What does it mean, a flag variable? The value false will signal that the user has not entered the correct password. Hence, the password correct is initialized to false when the program starts. And the value true will signal that the user has entered the correct password. So he will be allowed to play the game, okay? Explain now how the code is work. So look at this code. The code will ask the user to enter a password and set the variable's password attempt to the user's input, okay, to the answer. And if this value of this password is equal to the password already stored, okay, so it will set the value of the flag password correct to true, and set the animal variable animal to an animal name chosen at random from animals, and tell the user that the password correct. Now press your space bar to play I Spy, okay? Otherwise, you will tell the user that the password is incorrect. So you need one password to play, okay, this game. Okay, so it is the same thing when we have problem solving with selection, okay? So we need to design my algorithm and implement after that this algorithm in a program. So for example, how we can identify the need for selection. Okay, so sorry, we can stop here. Okay, sorry. Okay, we will finish this part of selection at the next tutorial. Okay, tomorrow, for example. So thank you very much for your attendance, for your participation. Okay, and inshallah see you tomorrow. Okay, tomorrow. Okay, thank you very much. Okay, thank you. See you tomorrow. Okay.